So we've been learning about how soils form, but let's have a look inside the soil now.
It's how when we look into the soil profile, we can learn so much by digging a cross section like this and by looking at the soil profile. Soil profile description, when it's done properly, can tell us so much about the processes that are going on in the soil. And we can do a lot of that actually just by looking with our eyes, by looking at these different horizons that occur in the soil, and occasionally just by touching little bits of the soil as we go through.
So these horizons are the bands of different colours and textures that we see in the soil.
Absolutely. A classic soil description would have a number of horizons. Typically, we would start off with an O horizon at the surface. This O for organic matter. This is at the surface where all the plants decay at the top of the soil, and then we go from the O to the A horizon. The A horizon is where all the kind of action is, where all the interaction between the minerals, the organic matter, the biota occurs in the A horizon. Then we go further down into the B. This is kind of an area where things have moved to from the A horizon, and ultimately right down below we have the C, and the C is the parent material. It's basically bits of broken down rock. So you think of the soil, it kind of forms from the bottom up. The C is where the parent material is, and then the top and the O and the A is where the action is around the plants.
And these horizons can be varying depths depending on the types of soil that you have, and actually you don't always have all of those horizons, do you?
No. If you dig a soil pit anywhere around the world, you find lots of diversity in the soils. You can learn a lot from that. But the other thing I wanted to say, Carly, is I wanted to really remind ourselves about the importance of colour. Colour can tell us a heck of a lot about soil. You can see really stark contrasts in colour in this example that we have here. You can see here very dark material here, which infers dark humus, dark organic matter, and then a much lighter, almost but not quite a reddy coloured soil here, and then different, more grey kind of colours down below. So we can assess colour, and there are ways of looking and reading about colour, and it can tell you different things about different processes.
So this profile that we have right here, we've got this really dark material, so that's the organic matter, is that right?
That's correct. We've got a bit of litter at the top. We've got a little bits of broken down plants that live on the surface. These kind of decay into this material. So we have a kind of O merging into an A horizon here at the top of the soil. This is the organic material that is decomposing and becoming merged into the A horizon.
You can actually see that.
Yeah.
You see it leaching, so moving through the profile and coming down into the more orange horizon.
Yeah, you can see almost blotches of colour emerging between the different parts. That's called eluviation, and some people call that process podzolization, which is part of the processes that go on in soils.
So what are the processes that go on within a soil in general?
Other processes that go on are called glaying. This is when you dig into the soil and you can see little patches of light coloured and rusty coloured and dark colours which reflect areas of different oxidation in the soil. Okay, so glaying is a very important process.
And that can be from the rain coming down, but also groundwater coming up,
yes,
can't it?
Yes, it can. And then in other parts of the world you have problems with accumulation of salt. That's salinisation. That's a real problem in some parts of the world. And also, of course, in some parts you get accumulation of organic matter, and that's peat formation.
Got some pretty good exposed soil here. What's this profile?
Well, this Carly, this is a great exemplar of a high latitude soil environment. Here we are in northern England, upland northern England, a high rainfall environment, very poorly drained, and classic example of how peat forms in these conditions. What we've got a lot of rainfall that comes onto the land surface, super saturated soil, it's absolutely full of water, and it's anaerobic conditions, so the stifled, the oxygen's reduced, the bacteria, the fungi can't do their job very well, and consequently, in very simple terms, all the grass, all the vegetation that's accumulated over the years can't decompose.
So all this black that we see in this soil that's the undecomposed organic matter.
Yeah, it's basically organic material. It's hardly got any mineral parent material in it, and consequently it's like kind of growing basically up from the surface. So if you just step back a little there, you can see that there are bits and pieces of rock around on the surface which will be the underlying parent material.
Right.
But here, actually, it can't really get to that because the peat is just growing because of the supersaturated conditions.
So how deep are these soils?
Well, it just really depends. This one, I don't know. I would imagine it might just go down a few more centimetres below where we can see. But these ombrotrophic peat bogs, these bogs can accumulate around the world in hollows where they're poorly drained, or also on the tops of mountains, on tops of poorly drained areas, and they can get to quite a few metres in depth in some conditions.
So vast stores of carbon then.
Vast stores of carbon, and an extreme example of soil processes really, peat accumulation, humic material accumulation.
Well, thank you very much for coming to talk to us about how soils form and about these soil profiles.
Thank you.